In today's session, Sylvie Liu and Christopher Romeo Munoz will take us through Fusion ML detections for emerging threats and configuration UI. Sylvie is a senior program manager with the Microsoft Sentinel team, while Christopher is a program manager with the same team. And without further ado, I'll turn it over to them. Sylvie, Christopher, the floor is yours.
Thanks, Jason. Well, thanks for joining the webinar today with us. So as Jason mentioned, the topic today is Fusion ML detections for emergent threats and configuration UI. We have Christopher from our 6C team to co-present the content for this session. So let's take a look at the agenda for today. We will first share an overview of Fusion, how it works, and then we will dive into the two new capabilities that we recently released into public preview, Fusion for emergent threats and the configuration UI. If we have time at the end, we will do Q&A with you. So Christopher will kick off the Fusion overview for us.
Excellent, excellent. Thank you so much, Sylvie, for the great introduction there. As Sylvie mentioned, we definitely have some really good enhancements when it comes to Fusion and what we're doing in that space to really detect unknown threats across your environment. But first, it's critical for us to really understand what is Fusion, right? We get, oftentimes we get a lot of questions when it comes to what is Fusion, what is the scope of Fusion, and what is it, what is the value proposition that it actually plays in Microsoft Sentinel. So before we even get started, when it comes to what is Fusion, I think it's pretty critical for us to understand the key capabilities in Microsoft Sentinel. When it comes to a SOC, the digital state is definitely expanding, so it's definitely critical to collect and analyze all the security data across your enterprise and have a single pane of glass in which you're able to bring that data to and be able to stitch together low fidelity incidents into high fidelity incidents. On top of that, we also have the ability to respond quickly and automate security workflows. And in today's age, like one of the biggest challenges today is that there's lack of automation across a security operations center. So for that reason, having a orchestration process or a orchestration service within Sentinel really helps to automate the manual tasks across your SOC. Now, on the right-hand side here, I have two different pillars that I definitely want to cover, and this is the ability to actually detect and hunt on malicious activity using threat intel and also AI. This is where the AI really comes into when it comes to Sentinel and also the machine learning process as well. We are able to increase the catch rate. We are able to enable the prioritization when it comes to incidents. And we all do that by having a correlation engine that is looking at your anomalies, is looking at your scheduled rules, is even looking at your third-party telemetry to be able to correlate that back to the cybersecurity attack code chain. Next, we also have the ability to investigate threats with an interactive attack graph. So after we are able to turn those low fidelity alerts and those informational alerts, which oftentimes are ignored, we turn those into a high fidelity incident, which we then provide you an interactive graph in which you're able to provide your SOC analyst an entry point to really understand all the entities that are part of the overall attack and to really understand the various activities that were executed throughout the entire attack phase. So it is definitely critical for us to have Fusion, to have this correlation engine, and to also have machine learning to really reduce the alert fatigue and to really increase the catch rate and also the mean time to acknowledge across your environment as well. So you're probably wondering, how does Fusion actually work? What is the funnel? Knowing that we have billions of signals and events coming into our SOC, how does it actually do it? So for Fusion, the whole scope is to be able to detect a multi-stage attack. So oftentimes, whenever a bad actor is across your environment, they're not just going to hit you with one big attack. They're going to creep in your environment, ignite low alerts and informational alerts, which oftentimes are ignored across a security operations center. But to be very frank, those small or low fidelity alerts, those are the ones that really fall through the cracks that overall are actually part of a bigger attack spectrum. So here what we're doing is that we are looking at all the activity across your environment. This includes multiple cloud services. So Azure, AWS, GCP activities. We're looking at your Office activities. We are also looking at the millions of events that are coming from your identity providers. And from there, we are then turning that down and bringing in and identifying all the anomalous signals that we're looking and we are analyzing from that telemetry. From that telemetry, we are then getting to the security alerts and all the anomalies that are currently across your environment. And then from there, that is where we add the icing on the cake. So we go a deeper level by adding the graph-powered machine learning that's currently automated and is on by default across Microsoft Sentinel. And we do that by also adding a probabilistic attack kill chain. So aside from the machine learning, we are actually correlating back to the attack kill chain to understand the various patterns in which you have correlation to when it comes to your environment. So here we have a quick example that I really want to dive into, and hopefully you have the ability to clearly see it. But for example, there was a identity that was compromised. From there, that bad actor, there was a suspicious document anomaly. And then from there, there was data exfiltration. So just based off these three different patterns or activities that we were able to see across your environment, plus the graph-powered machine learning, that is where we have some suspicious candidates. So those candidates, those leads, by adding another layer of scoring and also machine learning analysis, that is where we are able to turn those low fidelity or low and informational anomalies into high fidelity incidents. The reason why this is so critical is because, again, we are increasing the catch rate. We are analyzing all the telemetry across your environment, but we are taking into account various different sources. We are taking into account all the activity that is coming into your environment. We are also taking into account the scheduled analytic rules, the anomalies across your environment, and even now, which Sylvie will definitely cover that, the customizable anomalies that you actually customize across your Microsoft Sentinel environment. So it's super, super critical on how we're able to go from billions of signals and we're able to funnel it down into high fidelity incidents, keeping in mind the overall cybersecurity attack kill chain. Next here on the right-hand side, I have a quick screenshot that really shows an example of what a Fusion incident really looks like across Microsoft Sentinel. Fusion is definitely multiple, so you're always going to see more than one alert within a Fusion incident. Again, we are looking at various different stages. We are looking at various different sources. So you're going to see where, for example, here we have alerts that are low here. We also have some that are informational, and of course, we have some that are also medium as well. So we are looking at deep across every single spectrum across various different sources to be able to provide you that high fidelity incident. As you can see here, and again, Sylvie will definitely go more in depth when it comes to this example, we have a tactical timeline when it comes to each single event, where it happened, how it was executed. And again, this really allows a very clear view of how that bad actor was able to maneuver across your environment. So here, just a couple of points of why Fusion is very important. We understand that the alert fatigue is real. There's a volume of security events that really continues to grow, and this adds a lot more frustration to your SOC and really allows, increases the sophistication of attacks as well. On top of that, by being able to identify and combine low fidelity signals and being able to, elevate those to high fidelity incidents, this is really going to allow prioritization across your environment. This is also going to increase the mean time to acknowledge, because now whenever one of your SOC analysts sees that there's a Fusion incident and we have a high severity, they're really going to understand that something is really going on that is really impacting more than one entity. So we're also taking into account the entities and also the tactics when it comes to this detection here. Lastly, something else that I would love to add about the Fusion is that we often get the question of, is Fusion adaptive? Is the machine learning in Microsoft Sentinel, is it able to learn and is it able to react from the activities that are actually performed by the security analyst? And the answer is yes, 100%. We really recommend every security analyst to really provide input whenever they close one of the incidents that are part of Fusion, because the machine learning model is really learning from it. It is adapting, by it, and it is also reacting based on the classifications that you're able to specify whenever you close an incident. So this is really, really huge for the overall scope of being able to reduce the alert fatigue and also increase the catch rate across your environment. So quickly, so far we've covered what is Fusion, how are we able to funnel it down how we're able to go from billions of signals into high fidelity incidents, I definitely want to cover some of the what's new, the new enhancements that we have brought back into Fusion. So Fusion overall, we have 122 multi-stage attack scenarios that cover the overall kill chain. And again, we are covering the MITRE tactics. So this goes all the way from the initial access to impact. And then on top of that, we also have the ability to detect any potential ransomware activities. And we are really focusing on the defense evasion and also execution stages of the attack. Now, new this Ignite or within the last month is that we now have a new set of machine learning algorithms that are really able to detect emerging or unknown threats across your environment. We also have now a extended source. As I said before, data collection is really important when it comes to a SOC. It's also really important when it comes to how we're able to analyze and how we're able to get the correlation engine behind Microsoft Sentinel to really provide that stitching, when it comes to your incidents. Lastly, we do have a new configuration UI, which Sylvie will definitely do a great demo on that, which provides you the ability to fine tune the input and also the output of Fusion. As I said before, the biggest question we get, are we able to fine tune it? Are we able to provide our own custom input? The answer is yes, 100%. And we do have a new configuration UI that does just that. So we talked about data collection. Quickly, I want to talk about the Fusion data coverage and what we are able to provide here. So first off here, we have the 122 attack scenarios that we are able to satisfy out of the box when it comes to Fusion. Here we do cover Azure AD identity protection. We do cover Palo Alto network. So again, we are really focusing on the third-party data sources as part of the overall scope in order to be able to stitch not only the Microsoft first-party products, but also bring in your own third-party telemetry and being able to analyze and provide you that correlation to be able to have high-fidelity incidents. The next pillar that we have here is Fusion for ransomware. So Fusion for ransomware, we are taking a lot of the different products from Microsoft Defender, and we are also taking alerts from scheduled analytic rules. And this includes both built-in and also those custom analytic rules that are built by your security analysts. We are all taking that into account to provide you detections for ransomware. Now, the way that this works is that, for example, if we see that there's a ransomware prevented alert, we are really taking that alert as the seed. And then from there, we are trying to expand to really analyze across your environment during that specific time frame what other executions or activities happen that may correlate back to that original incident. So again, we are really looking deep when it comes to your environment to be able to provide you that additional context and that additional insight when it comes to leaks that may have happened. Lastly here, and this is definitely new, and this is what Sylvie will definitely focus on, is the emerging threats. So for the emerging threats, we are covering the customizable anomalies. We are really going deep when it comes to the Microsoft Defender suite, and we are also looking at the scheduled rules. But the customizable anomalies is really what really provides that icing on the cake, because now we are looking at anomalies on top of the other different data sources to be able to detect any emerging threats across your environment. So again, three different pillars here. It really covers a really holistic data collection here. And just to add on to this, you do not have to enable every single data source here, but of course, the more the merrier. The more that you enable, the more of detection that you're going to have when it comes to Fusion and overall in Microsoft Sentinel. And just shortly here, what I definitely want to cover is that for these scheduled analytic rules, they must contain kill chain tactics, and they must have entity mapping in order for it to be used by Fusion. So having the ability to actually use tactics across your analytic rules and also entity mapping, that's really going to provide additional context and additional insight so that the correlation engine is able to stitch together those low and informational alerts and turn them into low volume, high fidelity, and high severity incidents across your environment. So we've covered quite a bit here. What is Fusion? How does it work? And the Fusion data coverage, I think, is pretty critical for us to talk about the new set of machine learning algorithm, which is going to allow us to actually detect the emerging threats. So I'll pass it on to Sylvie to cover that.
Thanks, Christopher, for the great overview of Fusion. Now let me share my screen. Okay, so now let's dive into the new Fusion releases. I'll start with detecting emergent threats with Fusion, how it works, and how could the extended coverage help. Let's first see an example of the Fusion for emergent threats detection. Christopher shared a screenshot of the incident earlier, and as he mentioned, most of the signals we correlate in Fusion are lower severity signals. For this new detection capability, all the incident title will show as possible multi-stage attack activities detected by Fusion, and by default, these incidents are high severity in your workspace. So the example you see here shows a possible attack started with initial access from the cloud to endpoint execution, and then moved on to consistent beaconing from an internal IP address to a suspicious external one, which is an indication of possible data exfiltration. So all these suspicious activities happened in roughly 24 hours and are correlated on 3 entities: a suspicious IP address, a host, and a user account. Fusion detected this attack by correlating anomaly. So it's the anomalous Azure AD sign-in sessions and alerts from custom scheduled rules. There are 3 alerts triggered by 2 different schedule rules here in the incident. One is a distributed password cracking attempts in Azure AD, and the other 2 are from the Fortinet signal beacon pattern detected. There are also alerts from Microsoft products in this incident, including Microsoft Defender for Endpoint and Azure Defender, which is now called Microsoft Defender for Cloud. So once your analysts see this high severity incident in your workspace, they can quickly understand the TTPs in this attack and take immediate actions to stop the attack before more damage happens. After seeing the example, you might wonder how would the new set of Fusion ML algorithms can really help you find this kind of emergent threats in your environment. So as Christopher mentioned earlier, Fusion uses graph-powered machine learning for detecting multi-stage attacks. This new capability is an extension of the existing Fusion platform. So the new set of ML algorithms processes large-scale data set and identifies threat patterns through graph building and multiple pruning steps. The algorithm also constantly learns from known attack patterns, IOCs, analyst feedback, and the research from Microsoft internal security teams. Additionally, we also take the incident feedback from your analyst when you close Fusion incident as ML labels to train and improve our models. So want to emphasize again, providing accurate incident conclusion is helpful for improving Fusion detections in your environment. So next, I'll do a quick walkthrough on how Fusion identifies emergent threats at high level. So as you can see here, there are 2 phases. I'll explain in the first phase how Fusion discovers the emergent threats and TTPs, and in the second phase, how Fusion incidents are triggered in your workspace. During the emergent threat pattern and the TTP discovery phase, every day Fusion runs on large-scale data sets, that's millions of anomalous signals, to build correlations and subgraphs based on the entities extracted from these data. So these subgraphs are hyperconnected. Each entity is represented by a node, and the edges represent all the activities. So the entities can be an IP, a user, or an account or a host. The activities are in Sentinel. The activities are the alerts and anomalies from different sources. So the investigation graph in Sentinel also has the same concept. So you're probably already familiar with the graphs that we're talking about here. So Fusion identifies common patterns from these subgraphs based on characteristics including time of the events, kill chain intent, etc. You can see some of the simple examples here. The ones on the top represent the subgraphs formed, and the set of patterns on the bottom are discovered from these subgraphs. Of course, in real life, the graphs are much more complicated than what you can see here. The next step is to identify threat patterns by applying a round of scoring and ranking. So this is because not all the common patterns in the subgraph are considered as emergent threats. They do not always have the meaningful TTPs. So how this works in the second step is that we have a pool of known threat patterns based on the insights from security analysts, from the research done by Microsoft teams, from the past incidents, etc. Fusion constantly learns from the known threat patterns and then applies a round of scoring and ranking based on how the real security analyst thinks to identify those emergent threat patterns from the common patterns that we extracted from the last step. In the example here, only the pattern in the middle is considered as an emergent threat pattern, and the rest of the patterns that do not meet the bar are dropped. So this process is similar to how your security analyst manually correlates the signals together, associate them with kill chain, and apply their security knowledge and analysis to identify possible threats, except that Fusion is run at the cloud scale and processing millions of anomalous signals. The most important thing here is that every day there are new emergent threat patterns identified by Fusion, and these patterns are added to the pool of threat patterns. Because this pool of threat patterns is always refreshed and updated, Fusion can always keep up with the changing threat landscape and evolve with it. That's how this extended capability can detect the emergent and novel threats. Also, based on the data study, we can see many of the emergent threat patterns found by Fusion match what the security experts in Microsoft are seeing. The next phase is to detect the threats in your Sentinel workspace based on the known and emergent threat patterns that Fusion discovered. In this phase, Fusion forms subgraphs based on the data in your Sentinel workspace, and then identifies correlations that matches the threat patterns. Once these threat patterns candidates are identified, we apply a final round of scoring. Based on the results from this round of scoring, the threat patterns meet our threshold for publishing are triggered as high severity incident in your workspace. So the example we shared earlier is an incident triggered after these phases. One thing to note here is that a lot of the times a subgraph can still be huge and may contain way too much information for your analyst to go through. So for Fusion, we only surface the most relevant anomalous signals in Fusion incidents to help you further reduce alert fatigue and speed up the investigation. You can look at the 5 most relevant alerts versus 20 alerts that's related to the entity. So this helps you to narrow down the scope. And again, the feedback you provide for each incident, whether it's a true positive or false positive, will be used to train and improve our ML algorithms while it's finding emergent threats. So providing accurate feedback for Fusion incidents is helpful for improved Fusion detections in your environment. So with this high-level overview, I hope it helps you to better understand how Fusion detects emergent threats. So overall, end-to-end model is fairly complicated, and I hope these quick phases and steps would give you better insights on how Fusion works and how we detect emergent threats. We also mentioned earlier that we have extended our coverage with this new extended ML capability. So essentially, we hope Fusion can help monitor all your assets that you the source signals highlighted in blue, you can see on the right of the screen, that represents the extended coverage we have, which includes customizable anomalies, all the scheduled analytics rules that have tactics and entities information, and some additional Microsoft products. Like Christoph said, now Fusion has extended the coverage to all the built-in and custom scheduled rules. The detections can help you reach every asset monitored by a SOC team in an enterprise. That includes signals from endpoints, network, and multi-clouds, as long as you have scheduled rules set up for monitoring these data sources that you brought into your Sentinel workspace. We've heard from many customers that Fusion should support more third-party data sources. So with the support for all the scheduled analytics rules, this becomes much easier. For example, if you have third-party data sources such as Cisco, Fortinet that you brought into your Sentinel workspace, these data can be leveraged by Fusion if you have scheduled rules configured as we requested for Fusion. Like we need the tactics information, we need the entity mapping completed. Also, the schedule rule set up by your analyst reflects organizational and domain knowledge. So Fusion can leverage the alerts from these customer rules to identify threats that are more specific to your environment. The other new source signal Fusion can now leverage is the customizable anomalies. So the customizable anomalies are also ML-based. It can adapt to new behavior patterns in your environment. We know attackers, they always finding ways to sneak in, they're changing how they, their tactics and techniques. However, any attacks, they will still result in unusual behavior in the systems that being attacked. There will be traces. So this is where ML can help. Currently, there are about 40 customizable anomalies, and there are more that's coming up. With the ML-based customizable anomalies and the new set of Fusion ML algorithms, Fusion can correlate the unusual behaviors in the environment with other suspicious signals. So this is a great addition to help improve the detection quality and can also help provide more evidence during your investigation. So that's about the Fusion for emergence threats and the extended data coverage. The other release we recently had during the Ignite is the new Fusion Configuration UI. So it's currently in public preview. Here's a screenshot of the new configuration UI. Previously, you only have the option to enable or disable Fusion under the General tab, but now, as we're bringing in more customization for you to fine-tune the Fusion ML detection, you can see all the configuration options under the Configure Fusion tab. With these configuration options, your security analysts can fine-tune the input and output of Fusion. So for input, you will be able to specify the input signal sources to define the scope monitored by Fusion. For output, you will have the option to exclude specific detection patterns that may not be applicable to your environment from Fusion detection. The detection pattern here means the combinations of alerts or anomalies that you see in Fusion incidents. Now let's take a look at how to configure the input for Fusion and some of the use case scenarios. The list here shows all the source signals supported by Fusion. In general, we recommend that you include all the listed source signals to get the best result from Fusion. Also, same apply to the severity levels. So by default, when you open up the configuration tab, like all the signal sources are included by default. However, there are times that you do need to exclude signal sources or specific alert severity levels from fusion detection. So for example, if you're testing a specific signal source and there are many noises alerts from the test, you may not want Fusion to pick up these alerts and trigger a high severity incident that may cause more workload for your SOC team. So you can temporarily turn off the source signal until your testing is complete. Also, to security level, by design, the alerts included in Fusion are generally lower severity, medium, low informational, but occasionally relevant high severity alerts are included. If you have a specific process for triaging and investigating high severity alerts and would prefer not to have these alerts included in Fusion, you can definitely configure the source signals to include high severity alert to exclude high severity alerts from Fusion detections, so it's easier for you to streamline your SOC workflow. So when you exclude a particular signal source or an alert severity level, it means that any Fusion detections that leverage signals from that source or the alerts from the specific severity level, those incidents will not be triggered. And then next, it's about to configure the output of Fusion. The option you have is to exclude specific detection patterns if these are not applicable to your environment. So if you receive Fusion incident that represents a threat pattern that you consider noisy or not applicable in your environment, and you no longer want to see the threat pattern, meaning the same combination of alerts or anomalies in future Fusion detection, you now have the option to make the exclusion using the link provided in the Fusion incident. How it works is that once you identify a Fusion incident that contains a threat pattern that you'd like to exclude, you can select the exclusion link from the incident description. The pattern will be automatically added to the exclusion list, and all the future Fusion incidents that match the excluded pattern will no longer show up in your active incident queue. These incidents will still be triggered, but will be auto-closed, so you can go back and review them as needed. You can also remove the exclusion patterns anytime from the configuration wizard if you want to resume a Fusion incident that contains this threat pattern. Now let's see a quick demo of the Fusion configuration UI so you can see it in the Azure Sentinel workspace. So first, let's navigate to the Analytics tab and find the Fusion rule. To add it, click the button here. So previously under General, you have the option to enable and disable Fusion. Now, if we go to the Configure Fusion tab, that's where you can see all the configuration options. On the top, it's the configure source signals for Fusion detection. For here, we have 3 buckets for the Fusion source signals: anomalies, alert providers, and raw logs from other sources. For anomalies, now you only have all options to turn on or off all the anomalies. For alert providers, you do have the option to include or exclude specific alert providers from Fusion detection. For example, if I turn off the alerts from Microsoft Defender for endpoint, it means any Fusion detections that contains a alerts from Microsoft Defender for endpoint will not be triggered. If even if there are in the Fusion incident, there are alerts from Microsoft Defender for Endpoint as well as other sources, for example, Microsoft Defender for Cloud, scheduled analytics rules, and anomalies, this incident will not be triggered because you have excluded MDE from the source signals for Fusion. And then for configure severity, you can also here to decide what severity level you want to have for each alert provider. On the bottom here, it's the option for you to exclude specific detection patterns from Fusion detection. So you can see the list of the already excluded detection patterns here in the list. If you hover over, you can see the details of the alert providers and alert name that's included in the pattern that you excluded. If you want to review and dig more into the exclude pattern, you can copy it to a notepad or somewhere where you can do further analysis. Here you can also see the date and time when this threat pattern was added to the exclusion list, and then you have the option to remove it at any time. The next I want to talk about how do you exclude the threat pattern from a Fusion incident. So let's find a Fusion incident here first. Okay, let's pick this one. If you open any Fusion incident and expand the Fusion incident description, you can see a section called exclude the specific detection pattern. Here you can find the exclusion link. So for this incident, it contains two source signals. One is unfamiliar sign-in properties. The other one is from scheduled rule called insider risk, risky user access by application. So once you click the exclusion link, it will redirect you to the configuration tab, and then you can see this threat pattern has been added to the exclusion list. You can see the alert provider and the alert name as well as the time added. So if you want to confirm the exclusion, proceed to the next steps and save the rule. If you decided that you no longer want to exclude this pattern from future Fusion detections, you can click the trash can button to remove it anytime. I also mentioned earlier that the Fusion incident that match the exclusion detection patterns will still be triggered, but auto-closed, so they don't show up in your active incident queue. So let's also take a look at the auto-closed incident for the pattern that we already added here. So for this pattern, let's go find the incident. So because they will, the incident will be auto closed, let's select the status equal closed and severity as high. So this is an example of the auto closed incident that matches the detection pattern that we excluded earlier. So if you look at the status here, it's shown as closed. The reason for closing, it will be marked as undetermined, and the reason is auto-closed, excluded from Fusion detection patterns. So it's easier for you to recognize why this incident is showing up in the closed list. And also, some of you might be using an external tool to query and analyze the incident. So we're also adding a tag here, excluded Fusion detection patterns. So it's easier for you to search and query these incidents that are being auto-closed because of the exclusion. So that's a quick overview of the Fusion configuration UI, and these are some of the customizable options that we're bringing to you, and our team is definitely looking to bring more customizable capabilities to help you better manage the fusion detections. So if you have any feedback, we would definitely love to hear from you. If you would like to type in the chat and let us know what additional customization options you would like to see, that would be awesome. Okay, so that's all the content for today, and because we have some time left, we might be able to take questions from the chat. I know folks from our team is answering questions, and let me know if there's any questions that I can answer here, and we also have the team on the call, so we can help answer the questions if you have any.
Absolutely. The team's been on top of answering questions. I do have a few unanswered to bring up. First one is, how do you ensure you are not automating actions on false positive alerts that could impact an end user?
So for this one, Fusion correlates the signals together and trigger an incident in your workspace. So we're not automatically close an incident or take actions on an incident triggered by Fusion. So if there is a false positive alerts included in the incident, our recommendation is to close the incident as false positive, give us the feedback. So when we use this as the ML label to train the model, we know it's a false positive, and it helps us to improve the training. And if you could provide additional comments in when you close the incident, for example, specifically call out this alert is being considered as false positive, it will help us to get more information.
Great, thank you. Next one is, how have you been reducing the number of false positives according to each organization, information, and context?
You mean across different organizations, or I guess I'll need a little bit more clarity on this question.
Okay, we can come back to that. Yeah. The next one is, does Fusion detect beacons under 20 minutes with jitter?
So it really depends on the alert that is triggered on the beaconing pattern. So if there's alert or anomaly triggered on the beaconing, and it's relevant in one of the subgraphs, Fusion will be able to pick it up.
Great. The next one is something supposed to be included under the anomalies heading? Clicking on that just toggles the chevron and does not show anything.
Right, for now, we do not have an option for you to include or exclude specific anomalies. So for now, there's only one options to include or exclude all anomalies.
Great. The next one is, if I bring in logs from an application running outside Azure in a custom table, what do I have to do to include those logs in Fusion?
So if you can set up scheduled analytics rules for those logs, the scheduled rule will start triggering alerts in V3 format in your Azure Sentinel workspace. As long as you have that scheduled rule set up, you have configured tactics information and put in the entity mapping for the logs that you brought in, Fusion will be able to pick up those alerts triggered from the schedule rule that you set up.
Great. Next one is, what do you miss if you exclude MS365 Defender from Fusion, but include Defender for Office or Defender for Endpoints as an example?
So for example, if you I think it's very similar to what I walked through when I showed the demo. So if you exclude the incident from M365D, any Fusion incident contains an alert from M365D will be excluded, even if there's only one alert from M365D and there are 10 other alerts from different sources. This incident will not be triggered because that you excluded the source signal from M365D completely. So I would recommend you to be careful while you're configuring signal sources, because it may not just impact one fusion incident. It might impact all the future fusion incident that you get that relies on source signal from the specific one that you excluded.
Great, thank you. The next one is there a way for us to get a comprehensive listing of all the automation rules in our workspace?
I'm not sure, so we will have to get back to you on this.
Okay. The next one is, what is the best way?
Hold on, Jackson. I think the automation rules, there are two types of rules. One is the analytics rules, another is automation rules. And there is a automation braid, list all the automation rules. So I'm not sure the question is about analytics rules or automation rules. If it's a literary automation rules, Sentinel has an automation braid. You can click on the left configuration side, and then you see all the automation rules.
Great, thanks for jumping in, Sharon. The next one we have is, what is the best way to find any rules that need to be updated? Do we just need to scroll through them?
For any rules, so for the scheduled analytics rules, you will have to review each of the rules and figure out if those are configured correctly. So for fusion rules, there's only one rule that's under the analytics tab, so you can just go in the fusion rule and make the configuration as needed.
Great. And the last one we have is, have you explored a reinforcement learning approximation to build proactive scenarios, a purple approach to get more data that has not been studied?
Yeah, this is definitely something we've thought about, and we're definitely thinking on this direction. So that's a great suggestion.
Great. Well, thank you, Sylvie and Christopher, for being our guests today and for an excellent presentation. And thank you to the rest of the team who helped answer questions. At the same time, I would like to remind the listeners that the best way to ensure you don't miss any future webinars or major announcements is to visit our landing page at aka.ms/securitycommunity. And while there, you'll find easy ways to navigate and find the resources and learning content relevant to our security products in their communities. A good start would be browsing our bite-sized product videos, ninja trainings, recordings of past webinars, GitHub communities, and more. We'd love to hear your feedback on how we can improve these webinars. Please take a minute submitting your webinar feedback at aka.ms/security webinar feedback. Thank you and see you next time. Goodbye.